All right, welcome everyone to this webinar about rare earth elements. In this webinar, we will talk briefly about what rare earth elements are used for, why they are a hot topic in the EU, and what is happening in the EU to try to fix the issues that we will soon talk about. And we will focus on one of those avenues of fixing the issues, which is establishing recycling within the European Union. This webinar is hosted by Stena Circular Consulting. We are part of Stena Recycling, and we help companies establish circularity and foster circularity within industrial context and in other contexts as well. And you can see on the left-hand side here some of the themes that we at Stena Circular Consulting work with on a day-to-day basis. If you want to read more about us, you can use the QR code there on the right-hand side to get to our webpage, or of course you can also use a AI bot of your choice to ask questions about us and learn more about us. If you don't want to get in contact with us in person, of course, which is of course our preferred way of doing things. You can switch to the next slide, please. My name is Oskar Wallin Berlin, and I am a principal consultant at Stena Circular Consulting. But the two stars of the show that you will see here today are Fredrik, first of all, who is a senior analyst at Stena Circular Consulting, and he has been working on and running some of the critical raw materials and rare earth element studies that we have been conducting over the past couple of years. And the second star of the show today is Eugene, and he comes from CAREMAG, which is a company that is establishing recycling of rare earth elements and magnets in Europe. And Eugene will introduce himself a bit more later on in the session here. And I should say as well, Eugene, that we're very happy to have you with us, and we look forward to the presentation that you will share here in a moment. So what will we do today? We will first introduce rare earths and their use in magnets. And I should say that as well, that we will focus mainly on the use of rare earths in magnet, not general rare earths. Then we will look at European recycling, and here Eugene will share a little bit both about the landscape of recycling of rare earth elements and magnets in the EU, and also about the project that they are building in southern France with the objective to recycle the magnets. If you have questions during the session, which I hope you have, you can find the little button on the top of your screen, which says Q&A, or if you have a Swedish version, it says Frågor och svar, FNS. You can click that button and type your question, and it becomes like a chat function where you can load your questions. And towards the end of this session, I will read up some of those questions and we will try to answer them the best we can. I should say we also received a few questions through the invites before the session, and we will also try to answer some of those the best we can. With that said, let's dive into the topic.
Before we get into supply chains and policy, I just want to ground us briefly in why rare earths actually matter. If we look at a chart on the left, the EU assesses raw material circularity. The main parameters used to determine criticality are economic importance and supply risk, taking into consideration, for example, how important they are for European industry and how hard they are to substitute. The key message is that both light and heavy rare earths are considered highly strategic and critical materials by the EU. They combine high economic importance with high supply risks, which puts them in a very, very different category from most other raw materials. Now, rare earths are used in a wide range of applications, including catalysts, electronics, and optical technologies. But in today's context, we're mainly focusing on their use in permanent magnets, because that's where one of the most strategic dependencies sits. The specific materials are the heavy rare earths, dysprosium and terbium, and the light rare earths, neodymium and praseodymium. Both provide unique magnet properties. Permanent magnets, they account for roughly 30% of rare earth demand by volume, but about 95% of the value. So this is not really about material volume, it's about a strategic dependency. And the reason is that these magnets sit inside many of the most important technologies in the economy. If we look at the bottom of the right side, they are in energy and mobility, where they're used in wind turbines, electric vehicles, and e-bikes, for example. In digital electronics, they're in smartphones, hard drives, and speakers. And in industry and automation, they're used in motors, sensors, and all kinds of robotics. And also in strategic sectors. They appear in medical equipment, aerospace, and defense systems. So the key takeaway here is rare earth magnets are not just another materials issue. They are a cross-sector enabler for technologies driving both the green and the digital transition. So if rare earth magnets are this important, the next question is, where does the supply actually come from? And this is where the challenges become very clear. Today, the EU has very limited installed capacity across the magnet value chain. And looking at the chart to the right, around 59% of mining is concentrated in China, around 91% of refining, and around 94% of magnet manufacturing. So the concentration increases the further downstream in the value chain you go. There are some exceptions. For example, France has niche refining capabilities, and Japan has been actively trying to build up magnet manufacturing for a number of years now. But even with those efforts, the global system remains highly concentrated. And this is important because the real bottleneck is not just mining, it's refining, processing, and magnet manufacturing. So what Europe is exposed to is not only access to raw materials, but access to the stages where value is created and where supply cannot or can most easily be constrained. And that creates a structural vulnerability, because when magnets underpin energy, mobility, electronics, automation, and healthcare, this becomes an industrial resilience issue, not just a sourcing issue. So the key message is Europe is dependent on a very narrow and concentrated supply chain for one of its most strategic material applications. And that is exactly why the EU has started to intervene much more actively. And this is where rare earths move from being a materials topic to becoming a question of industrial policy. The EU's response is built around the Critical Raw Materials Act, and the targets for 2030 are shown on the left. 10% extraction in Europe compared to the demand, 40% processing, and 25% recycling, and no more than 65% dependency on any single country. So the direction is very clear, reduce concentration and strengthen the value chain in Europe. The first lever to do this is to diversify supply chains through global partnerships, and this is already happening in practice. In 2025, the EU announced a total of 60 strategic raw materials projects. 13 of these are strategic projects outside of the EU, specifically aimed at securing access to critical materials across different regions. Examples include projects in countries like Serbia and South Africa, as well as partnerships in other regions with resource potential. So the idea here is not to eliminate imports, but to reduce dependency by building a much broader and more resilient supply base. The second lever is to mandate circularity through policy and product design. And this is really a key shift where circularity is no longer just about sustainability. It's becoming a supply security tool. For example, under the Critical Raw Materials Act, the EU had introduced a 25% recycling target, as well as requirements around magnet disclosure in products, removability, and use of recycled content. So the goal is not just to recycle more, it is to make sure materials can actually be recovered and retained within Europe. So in other words, to turn waste that is lost in today's system to other material streams into a strategic resource. And the third lever is to build domestic capacity through targeted investments. Here, again, we're starting to see concrete projects. The EU has identified 4 to 7 strategic projects within Europe, covering extraction, processing, and recycling. And 5 of these are specifically related to rare earth magnets, where LKAB's mine in Luleå is one of them, which just got its environmental permit approved. So this is not just about targets. It's about building real industrial capacity across the value chain. So overall, the EU is trying to move from a model based on import dependency to one based on diversification, circularity, and domestic capability building. But targets alone do not create circularity. They create the need for circularity. And the real question then becomes, how do you actually build this capacity in practice? And that is exactly where industrial initiatives like CAREMAG become critical. So with that, I will hand over to Eugene, who will take us from policy into how this is being implemented on the ground.
Thanks a lot, Frederick. Hello, everyone. Thanks for the perfect introduction. Thank you, Oscar. Thank you to Stena Circular Consulting team for this hosting this webinar. My name is Eugene Darona. I'm from France, and I'm working for CAREMAG, as it has been mentioned. CAREMAG, who are we? We are a subsidiary of Carester, French company, same company, and we are based in France, and we are building an industrial plant in France that will be very soon ready to produce those rare earths and rare earth oxides coming from the recycling of the permanganate and the refining of mineral concentrates. And this is the reason why basically I'm happy to share with you some insights about the challenges and opportunities, solutions that we can bring to the evoked issues that Frederick has brought. Everything starts with the rare earth value chain, as it has been mentioned. You may have already heard about permagnets, which are at the end of the value chain, but basically everything starts from the mines, where you will extract all the rare earths all together. And the challenge basically is not really to find those rare earths, but to purify them with the 2 families that has already been mentioned. I will not repeat them. We have the 4 magnetic rare earths, the praseodymium, neodymium that you can see above, and below in green the heavy rare earths, which are more used to dope the magnet. It means that the light rare earths are in all the magnets, and the heavy rare earths may be found to help the magnets stabilize in high temperatures. So for instance, in electric motors, etc. Once you've purified the rare earths, you still need to do the metal and alloy, and finally do the magnet production. And what I want to stress here is that the volatility and the risk for us in this supply chain as industrial is really on the oxide, so on the raw material that are used to produce the permagnets. And especially I want to point out that the heavy rare earths, which are again used as dopant, are today 100% separated, refined, in other words, by China, meaning that you have a global dependency on rare earths, but on certain types of rare earths, such as heavy rare earths, so again, terbium, dysprosium, for instance. If you have 0.01% of those heavy rare earths in your magnet, you are somehow at risk because you are depending on one single country. If we take some general statements at the industry level, what we can say as industrial is that we need to combine definitely private initiatives like CAREMAG that should be viable for sure. The idea is not to subsidize in industrial companies, and to combine this with a regulatory framework that has been also evoked by Frederick, for instance, with the Critical Raw Material Act or national policy. So it's a combination of both. Then for sure, recycling is very important, and I would say it's the ultimate target, but we should not forget the rest of the value chain. Reason why we wanted to stress this whole value chain, including the refining, including the metal production, including the magnet production. So it's a whole value chain we need to reinstall in Europe. And last but not least, so you have two recycling routes for permanent magnets. One, which is our recycling route at CAREMAG. It is the long loop recycling. We start with the magnets and we get out the individual rare earth oxides. So we do chemistry to recover the individual rare earth oxides that are contained. And the other route is the short loop. Short loop starts with the magnets and try to redo magnets with, if possible, the same properties. So both routes are complementary, and this is the important message we want to convey as well as an industrial actor. Then, so we are a French company, and I need to say not only because we are in France and we are very proud to be French, but France has somehow a leading position and has been at the forefront of this evolution and this awareness about how to bring some more sovereignty on rare earths. First, the government has managed to relaunch different companies, or has supports and backed, including CAREMAG for sure, but not only in the refining, in the recycling, in the metal making. So you see here different companies. The French economic minister, Roland Lescure, was, just to illustrate, last month in our company. So you can see CAREMAG here, and our president, Frédéric Caroncotte, near the French economy minister. And he was announcing a French national rare earth plant for more sovereignty on rare earths, including several measures. For instance, to give an incentive for automotive OEM to do independent plans on rare earths, so on how to de-risk this supply chain. Same for the wind energy industry. There are plenty of measures. I cannot mention all of them, but really France has been very proactive, and somehow we are proud of it. It's not a French topic, it's a European topic, but somehow each country needs to take some, and we have some capabilities here in France. Now, when we narrow down the scope, we at Carester, so Carester is somehow the mother company of CAREMAG. CAREMAG is the industrial project, and Carester is a leading company in rare earth processing. So we have a unique knowledge about rare earth processing, rare earth separation, and we are advising mining rare earth company everywhere in the world outside China. So rare earth is a very small market, and we have a leading position on this. But our CEO wanted to have his own industrial project, reason why he launched in 2020 the CAREMAG project. And CAREMAG is a strategic project, like Frederick mentioned. We are among the strategic European project, and we are building a plant in France currently to, again, produce those rare earth oxides coming from the recycling of magnets and the refining of mining rare earth concentrates, and especially those heavy rare earth concentrates, as you remember, that are 100% currently separated in China. Where are we in terms of progress? We have secured the investments in 2024, more than 200 million euro. So we are still a small company, but this is already quite an amount of money. thanks to two strategic investors. First, France, for sure, and the second one is Japan. That is, again, often taken as an example for rare earth critical minerals securitization. So we are very proud of it. The construction is ongoing regarding the plant and will be ready by end of this year. So this is coming soon. This is not just science fiction. This is something also we wanted to convey. This is happening and this is changing, and we'll soon have these plants ready in the southwest of France. Then again, if we get even more concrete, what I wanted to share with you today is really what are the challenges that we face in Europe regarding the recycling of permagnets. Why does it not happen as much as we would like? The first challenge is how to identify the feedstock, because Frederic mentioned a few sectors that are using the magnets. Basically, magnets are almost used everywhere, so this is very tricky. So in various types of application, loudspeakers, phones, MRI, etc. I won't list again all the sectors. And not all similar applications contain the magnets, rare earth magnet. What I mean by that is, if you take, for instance, air conditioner, so air conditioner compressors, some of them are using the rare earth, so the rare earth permagnets, and some of them do not use the permagnets. Sometimes you need to sort out the equipment, and it's a bit tricky if you do not know precisely where you will find them. Last but not least, the weight of the magnets inside the parts, inside the application, is very variable, meaning that it can go from grams, small quantities of magnets, up to tons of magnets for the wind turbine, for instance. You will find approximately at least 1 ton of magnets in each wind turbine. So there is a high variability. The second challenge is the recyclability. So it's very difficult, or not that easy, I would say, to extract the permagnets. First, because sometimes they are very small. Sometimes, so not sometimes, they are always magnetic. So they are attached to steel, attached to the parts, I would say, and there is no real eco design, to extract those permagnets. Furthermore, we don't really have as such a dismantling industry as such. There is no real company that is established. It's changing. I mean, but that is established and with the mission to extract those permagnets. Third challenge is the technology independence. If you don't have any more expertise in Europe, like we had in the past, in the 80s, Europe was separating, so refining 80%, 50%, sorry, in the 80s, 50% of the rare earths globally were refined in France. So we lost somehow the expertise years after year. So it's a challenge. And we have then some associated rare earth export control risks that you may have heard about, for instance, last year, that are associated to this technology independence item. Then the export risks. So currently 1% of permagnet are being extracted and recycled in Europe. So it's very low. It's changing a lot thanks to our initiatives and the colleagues as well in the industry. But still it's very low. And reason for that is it's somehow difficult to extract the magnets I just spoke about, but it's also that some magnets are escaping, meaning being exported outside Europe, so going back to Asia, to other continents. So for sure, it's a shame, and we are doing our best to avoid this to happen. Then there is the quality challenge, because if you do everything right, that you have the recycling process, you are independent, but then you don't reach the quality in terms of recycled materials, and this does not only apply to the rare earth elements. When you do the recycling, you need to fit the OEM specs, or OEM or tier 1, tier 2 to the industry spec, which is very demanding in terms of rare earth, should it be for the automotive industry or wind energy industry. So again, it's an additional challenge. And last but not least, but do not forget, I will bring some solutions to those challenges so that you don't stay like this. The last but not least challenge is the economic viability. meaning that, again, if you do everything right, you have the recycling challenge, you have the feedstock, you have the quality of the product, but your recycled product is, I would say, 5 or 10 or 15 times more expensive than the conventional product, that it will be very difficult for you to find some clients, to find some demand for your recycling products. So for sure, it's very important to be competitive and economic in what you are doing. So these are the 6 main challenges that we identify, and we can continue to the next slide to outline what solutions we can bring. So we'll start from the beginning and follow the same order. Regarding the feedstock identification, CAREMAG has developed a full database with years of experience since 2020 and the beginning of the project to know precisely where the magnets are, in which applications, in what quantity, is it difficult to access, etc. We have all the info about this, and we know precisely, depending on the rare earth content, when it's relevant or economically viable to extract those rare earths regarding the different applications. Here we target either the pre-consumer, so meaning the scraps that are not being into, for instance, the electric vehicles, because you have some production or manufacturing scraps and off-spec product, or it could be also post-consumer, so more at the end of life of the product. So these are the 2 main areas that we are targeting. Then how do we solve the recyclability? We are able to accept any kind of magnet. So this is the beauty of the long loop. We are going to do chemistry on the magnet, meaning that we don't care if the magnet is oxidized, if the magnet is broken, if the magnet, whatever you can imagine, any impurity, epoxy coating, etc., is not preventing us to recycle the magnet. So no challenge, no incoming challenge to the recycling process. We can recycle basically 100% of neodymium materials inside the plant, which is good, because if you start to have too much constraints, it's very difficult. And we have also developed an expertise on how best to dismantle those magnets from the different parts or applications. So should it be a rotor, an electric motor, etc. So we have a site in France where we are doing this, and we are in a partnership mode with local recycler. Should it be in Sweden, for instance, in basically in every country, so in France, Germany, so could be a Stena or any kind of other recycling companies, in order to be associated and dismantle locally and only transport the magnets to France and not transport tons of material to recover only kg of magnets. So partnership mode. Then in terms of technology independent, I've mentioned that we have with old and experienced colleagues that have worked in the rare earth industry, who are very experienced on how to purify the rare earths. And we are also technology independent in terms of know-how, also in terms of equipment, where we source our equipment for the plants, meaning mainly and nearly 100% of the equipment are coming from Europe, nearly, so we are putting a lot of effort on this. For sure, we're getting export. It's better to recycle in Europe versus Asia or North America. This is something common to all the industry, all sectors, but it also applies to rare earths. And what I want to say here is that we can combine local recycling, environment, and also competitiveness, because if you promote local recycling but then you are not competitive, again, you are falling into the same issues. Then quality, the recycled oxides, so the rare earth oxide that we are going to be producing, have the exact same quality compared to the virgin oxides. You will not be able to differentiate them, which gives you a strong advantage, because you have no quality downgrade, and then you can close the loop and recycle indefinitely the magnets, independently also of the incoming composition of the magnet, because all magnets are different. But we as CAREMAG, we don't care. We take everything, we produce pure rare earth oxides to reintegrate these oxides into the value chain. And last but not least, with the economic viability, very important. We have already secured more than 50% of the sales with off-take partner, long-term off-take partners, not sports deals, with Stellantis, so automotive industry, and the Japanese partners that are backing us also for the investment. So we are in a position to. It's not very. The major challenge is not to sell really the product, and we are actively sourcing the permanent magnets and buying every month tons of permanent magnets or equipment containing the magnets to dismantle the magnets and release more value for the industry, should it be for the recyclers, for the OEMs, etc., etc. So this is it, how we aim to solve the problem. Still some work to do, but we believe in a rather good position to move forward on all those items. And I will finish just in terms of being very concrete. And I will be done with my last slide, please, Frederick. How can we make it happen? Because you may have either some feedstock of magnets or parts or equipment that you are wondering if you have magnets inside, if this is valuable. So the first thing to do is to identify those sources of magnet materials containing potentially rare earth magnets. To validate if we know lots of application containing the magnet, so we'll be in a position to give a feedback on this. We usually, like in any industry, can sample because all magnets are different. So the value of the magnets, if we don't buy the e-scooter or e-bike magnets, same as EV magnet, for instance, all magnets are different, but we can sample in order to confirm the value and give back a buying offer either on the magnets, should they be magnetized or not, we don't care. And then we can take care of everything in terms of facilitating your life doing the transport, is right. So it's not something very complex. We have the knowledge to help and support, and we remain available if you have any concrete topics that you want to raise after this webinar to follow up on this. And it will be a pleasure for me and for the Stena Circular Consulting team to take your questions right now. Thank you very much.
Thank you, Eugene and Frederick, for presenting. I will turn on all of our cameras. We have a couple of questions, or one question coming in during the webinar here. If you have others, please feel free to share them through the question and answers function there. In the meantime, I will take a couple of questions that have come in before as part of the invites or the sign-ups for the webinar. So first question, from what application or product group do you think it is most efficient to recycle rare earth elements from magnets? Who wants to start answering? Frederick, do you want to give it a go first?
I get that one. Yeah, so it's probably going to be from wind turbines and from EV traction motors as well.
And why is that?
The wind turbines, they've been on the market for a while now, so we'll soon start seeing increasing volumes of wind turbines reaching end of life. But it's still some time to go, a couple of years. And for the EV traction motors as well, they've been on the market for, probably 10 years now, roughly. And we'll soon start seeing more and more cars going to end of life as well as repairs and total loss vehicles as well.
Excellent. Do you want to add anything, Eugene?
Oh, that's very clear. Again, that are the major sectors. Then you can find in some industrial applications. I believe also in the Nordics could be industrial motors. This kind of, you may have some companies active in this field. But this is pretty much.
Excellent. All right. Another question that came in here as part of the sign-ups was, how do you see the availability and recycling potential of rare earth metals evolving in Europe over the next 5 to 10 years? Who wants to take that one? Frederick, do you want to give it a go for this one as well?
Good question. I don't know. I think Eugene has better answer for that one.
Yes, I mean, there are thanks for the question. You have some lots of existing projects, basically. Most of them are in the so-called list of strategic projects, again, that has been mentioned in in this webinar. So we are somehow lucky that we have some existing, either existing industries or companies that are starting new business. Should it be on the mining, it's also applicable to Sweden, for instance. You should be very proud of it, even though it's a long term, because when you start a mine, it's not overnight that you will have the product. Refining, we have mentioned, mainly in France. Metal, there is LCM, less common metals, that is installing also. They will be established in France very soon. So again, not promoting France, but this is what happens really. And recycling, you have some initiatives in France, some other actors, Germany also, in the UK and Ireland as well. So in terms of timing, it's difficult because we need to go on the market, you know. The many projects are starting very soon, which is again something that we need to remind. This is not only theoretical project. So probably in some months or very few years, we'll have some more concrete answers to this question. But I'm optimistic, definitely.
Excellent. So it sounds like a lot is happening there in the next coming years here. I read from the list there, and one related question, I think, was what is the prognosis of when we will no longer be dependent on China for materials? So it's hard to look into the crystal ball into the future, right? But if we can say anything on that.
Who wants to take this? This is an issue of diversification. I mean, you cannot be independent when you have a dependency of 95%. This is not the target. Our aim is to help Europe to gain more sovereignty on this. Reason why also we have those heavy rare earths where we plan to produce 15% of the global demand for heavy rare earths. So 15% is not 50%, but still you start to be in the game, you know. If you are only 1% and you cannot see your production in Frederick's graph, then it's more difficult. But we need to take step by step, you know, because you cannot reduce a reliance again overnight by 50%. It's a matter of having the production, having the support of the government, having viable initiatives, having the OEMs and the clients being committed also as well. So it's everything needs to align, but it will take for sure some years. And demand is expecting to grow as well. Demand for rare earths, for other applications, robotics, AI, etc. So we never know where we'll be in terms of demand for the future as well.
Excellent. I see a couple of questions are starting to come in through the Q&A function here. I will take from the top as I see them. First one being, is the CAREMAG technology able to recycle other magnet types listed in the CRMA Act, e.g. SM cobalt, I suppose it is?
Yes, so neodymium iron bore magnets is the most. Thanks for the question. Sorry, neodymium iron bore magnet is the most common application. So if you have magnets, it's very likely that you have neodymium iron bore magnet. Though you have some other magnets such as samarium cobalt that have a value. We don't recycle them yet. So the short-term answer is no. But if you have some feedstock or opportunity, feel free to reach out because we have some connections, so we can still find some solutions for you.
Excellent. Another question that has come in was how will you do extraction of rare earth elements from hard drive magnets? Which technology or partner would you prefer? I think this is a two-step question, right? First, how do you mechanically take out the magnet from the hard drive, and then how do you extract the magnet materials?
This is a good question. I cannot disclose secret, but still I can provide some insight for sure, because you need to understand. It's very important to understand also that this is an evolutive industry. 1% of magnets are recycled. It means that we are working a lot to get those numbers higher. I mean, and it's one of the way to do this is to improve the dismantling. So mechanical dismantling is not very efficient because very few grams in the hard disk drive. So either you can cut the magnets and extract them before they have been shredding, or it could be after the shredding of the rare earths of the hard disk drive, because the value of the hard disk drive is more on the PCB, more on those metals. So our idea is not to reinvent the wheel, but more to plug ourselves with the existing valorization stream and to recover somehow a fraction containing neodymium. And for this, the asset is that we don't need to have pure nice magnets, so to take out by hand the magnets in order to purify them. So we are still working on the solution, but same, feel free to reach out if you have any feedstock or any opportunity of this. We'll be happy to answer.
Excellent. And perhaps last question before we close here. How energy intensive is CAREMAG's solution? You mentioned that you run the long loop. Perhaps you can use just 2 or 3 words on describing what you actually do in the long loop as well, perhaps.
Yes. We didn't have time for sure to go through all the, for instance, environmental benefits, because I mentioned the equipment that we are using most of the equipment in terms of sovereignty that are coming from Europe, and same, we are taking some proactive measures on the environment, and will recycle, for instance, 80% of the direct CO2 emissions of the plant will consume only electricity, no gas in the plant, no liquid effluent. So we are taking a lot of measures on this. We assume that we have 60% less CO2 emissions compared to similar process outside Europe, so mainly in China, because they are doing also recycling in China. So 60% could be a final figure, I would say, but we are very at the forefront also of this environmental measures to have the state-of-the-art plan from the beginning, and not doing the decarbonation plan in some years. So yeah, very ambitious plan on this.
Excellent. Thank you for that, Eugene. And I see that time is running out, and I see the participants number is starting to drop as well. People probably have meetings here at 2 o'clock. I would like to say special thank you to you, Eugene, for joining this session and answering questions and presenting to the crowd. Fredrik as well for a good presentation, and everyone, thank you for joining the session. And we are keen to hear from you if you want to discuss around this topic or anything else, of course. You can, of course, as I said, click there on the QR code that just disappeared if you want to see our webpage.
Thanks very much.
Thank you, everyone.
Thank you all.